Hi, my dear student. I welcome everyone to my video class. I think you have watched my previous videos. Let us continue our discussion in chemical kinetics. Please, careful. Make the notes. If you have any doubts, don't worry to message me. I will clear. Okay. Today I will go to this particular topics. First order reaction. Previous we have discussed zero order and all aspects of zero order has been discussed. Here we will go to the first order reaction. What is the first order? We have already discussed in previous videos. Don't forget to watch that. Please watch it. Now consider a first order reaction. A gives P. Right law expression of the first order is R is equal to K into concentration of A. K is the rate constant. Three general examples: decomposition of H2O2, N2O5, etc. Radioactive reactions, acid catalyzed hydrolysis of ester. Okay, now we will go to integrated rate expression of the first order reaction. Integrated rate expression of the first order reaction. Consider first order reaction. R is equal to K into A. Now what is R? R is equal to minus dA by dt is equal to K into A. Equation number 1. Now rearrange equation 1. What you will get? Minus dA by A is equal to K dt. Put it as equation number 2. Integrate equation 2 within the limits. Therefore, I put the integration A0 A minus dA by A is equal to K 0 T dt. Okay, what is the integration of this? Integration of 1 by x or 1 by a is equal to ln x or ln a. Therefore, we will get minus ln a0 to a is equal to k t 0 to t. Okay. Now apply limit. Therefore, when you have minus is common. Then you apply this ln a minus ln a0 is equal to k t minus 0, that is okay. Or it is ln a0 minus ln a is equal to kt. Okay. Now we can write in different forms. Okay. Different different forms of first order reaction. Okay, first is ln A0 minus A is equal to K. Equation number 1, suppose, because you know ln A minus ln B is equal to ln A by B. This is mathematics. Obviously you remember it. Second is 2.303 log A0 by A is equal to KD. Question number 2. Because ln A is equal to 2.303 log A. This is another mathematics. Let me check the video. Okay, fine. Yes. Now third, I just rearrange this. A0 by A is equal to e raised to kt, or put the A here. A is equal to e raised to kt here, that is A0 e raised to minus kt. You have a equation number 3. This is a third equation. Okay. This is also first order equation. Fourth is, we can rearrange this equation in another version. That is ln A is equal to minus kt plus ln A0. Ln A, this has put in here, minus sign has been put the other side. You will get like this. Equation number 4. Similarly, you have another equation. Find log A is equal to minus kt by 2.303 plus log A0. Question number 5. Okay. These are the different forms of the equation. Therefore, these all are considered as first order equations. Now, if you want another equation, you can write like this. This is also k is equal to 2.303 by t log A0 by A. So, another equation, please remember. Or 7, t is equal to 2.303 by k log A0 by A. My dear students, you should have all these equations in your fingertips. Then only you can solve the questions. Otherwise, you will be confused. You can make all the equations. Okay. Now I go to graphical expression of first order reaction. Next is graphical expression of first order reaction. First order reaction. These are very, very important topics. Particularly graphical expression of different orders of the reactions. Therefore, whenever you see a graph, you should be able to identify which order is represented by that graph. Okay. Yes. For that, you should have all these equations in your mind. The first graph. Okay. The first graph. Graph number 1. I have 7 graphs. You see all the graphs. First is concentration versus rate. You have this type of a graph. This graph represents the equation rate is equal to k into A, where slope is k. Fine. Second graph is concentration versus time. Concentration versus time. This is a graph like this. You know which equation represents this graph? Concentration of A, reactant A. This is reactant. This is represented by A is equal to A0 minus e raised to kt, exponential decrease. Now third graph, suppose you draw a graph of concentration of product versus time. How will be the graph? Product initially 0, exponentially increases. If reactant exponentially decreases, surely product will be exponentially increased. Fine. Now the next graph, suppose a graph like this. Ln A versus time. You know how will be the graph? The graph is like this. Which is the equation? Ln A is equal to minus kt plus ln A0. So this is y is equal to mx plus c4. What is the slope here? Slope is equal to minus k. Now suppose I draw a graph like this. Log A versus t. Graph will be like this. The equation is log A is equal to minus k by 2.303 t plus log A0. You know what is the slope? Slope is this. This is a slope. Slope. Okay. Now suppose you have a graph like this. A0 divided by A versus T. A0 divided by A versus T. Okay. What is that equation? A0 versus divided by. That is, you know, A0 by A is equal to e raised to kt. We have such an equation. A0 versus the graph is ln A0. So that is an exponential increase. Ln A0 by A is equal to kt. You have such an equation. We learn such an equation. Okay. Therefore, the graph will be like this. Very, very important. So I get the jump question. Okay. Ln A0 versus. Now, the last graph. I draw last graph in this. Suppose you have a graph like this. Ln A by A0. T graph. How will be that? Ln A by A0, it will be minus kt. Am I correct? It will be minus kt. Therefore, how will be the graph? The graph will be like this. Slope is minus k. Dear student, this graphical expression is very important. You don't belittle this idea. When you write any competitive examination, you can expect graphical questions. They will provide a graph and they will ask you which order is represented by the graph. Okay. Now I introduce you another equation for first order reaction. First order rate expression in terms of pressure. This is also very important. All previous questions are equations are expressed in terms of concentration, but same first order equation can be derived in terms of pressure. I am not going to derive that equation. You can do that But I introduced the equation because it is very important for competitive examination. This equation is valid when your reactant or product containing pressure K is equal to 2.303 by T log P0 by Pt, but there is P0 minus Pt, a small difference, a small additional number, P0 divide up P0 upon P0 by Pt. Here n minus 1, here n. What is P0? Initial total pressure. What is Pt? Pressure after time t. What is N? Number of moles of gaseous product. Underline, number of moles of sum of number of moles of gaseous product. Sum of number of moles of gaseous product. Okay. Please by heart all this equation and understand. In next video, I will solve the questions for better understanding of this equation. Okay. I hope you understood the video. Thank you for watching. Have a nice day.